Okay, guys, welcome to week 6 of your IT 210 Fundamentals of Programming class. I want to create a brief tutorial on your checkpoint this week and kind of go over what's required and kind of look at what they give you for this checkpoint. So I'm just going to dive right in here. I posted to your discussion board to the main forum your week 6 checkpoint, the rubric, and what the actual assignment is. So let's just kind of look at that real quick. For your rubric, it's very simple. You just need to answer all the questions correctly that are listed in the syllabus for this checkpoint, and that's worth 30 points. And the questions are, there's 9 of them. Okay, so approximately each question's worth a little more than 3 points. But let's just kind of go through each one of these questions, and these are in your syllabus, but I posted them to the main forum also. Let's just kind of go through each one of these questions and make sure that you guys understand them. Okay, so in order to answer these questions, you need to use Appendix J. So go into your materials section and download Appendix J. It's going to look something like, let me pull that up real quick. Hang on. Okay, here's Appendix J. So basically, Appendix J is pseudocode. You guys should be very familiar with pseudocode by now. But basically, the user inputs a value called x, and you know what? This is kind of not the best pseudocode in the world because they don't tell you how x was declared. We're going to assume it's an integer. Okay, so x is an integer that the user inputs, and what it does is it basically looks at x with a bunch of conditional logic here. And using this conditional logic, it outputs or displays certain statements, right? Okay, so basically what you guys need to do is look at Appendix J here, look at the pseudocode, and you should be able to determine, using the pseudocode, you should be able to determine the answers to these questions. So let's look at these questions here real quick and see if there's any kind of gotchas, because I'll tell you, some of this material is just needs to be updated. But okay, let's look at these questions in relation to Appendix J here. Question 1, what will be printed if the input is 0? What they're referring to here is if x is equal to 0, what is going to be displayed? That should be fairly obvious if you know how to kind of use the pseudocode, and I can't really give you much more information than that. So what is output when the user inputs 0 into x here? Question 2, what will be printed if the input is 100? So if x is equal to 100, what's going to be displayed? What will be printed for question 3? What will be printed if the input is 51? So if we set x equal to 51, what's going to be displayed? For question 4. And for all of these questions, just use a Word document, copy these questions into a Word document, and then provide the answers right below those questions in a Word document. Question 4, what will be printed if the user enters wingding? Okay, so wingding, you know, I don't know if they're actually saying that the user enters in a string here into, you know, this x variable, which they're not showing you how that's declared, so that's kind of poor on their part. But just assume that wingding is also a special font that can be used in order to basically enter in weird characters into the system. So regardless, if x is declared as an integer and you try to, it's basically asking you what happens if you try to enter in some weird character or some string that is not a number. So what happens if you put a non-numeric value into x? Okay, that's what question 4 is asking you. Okay, so give me an answer for that. Okay, question 5. Is this design robust? Okay, it's asking, is this a good design? And I will go ahead and tell you guys that there is at least one bug in this pseudocode. I can't tell you what it is, but there is at least one bug here. So if you guys can state what that is, that'll definitely help your answer for number 5. There's also some other things that can be optimized with this current code, and if you can list those for your answer to number 5, that will also help. Okay, number 6. How many levels of nesting are there in this design? Okay, what is nesting? Nesting is anytime you see indentation within your pseudocode. And what does indentation here mean? Indentation means that this code only executes if the level above it is true. Okay, so for example, for this first if statement here, you can see that there's one level of indentation because this code will only be executed if this if statement is correct. Okay, so nesting is basically how many levels deep does this indentation go. Okay, so for example, if you had an if statement within an if statement, now all of a sudden you have 2 levels deep. Okay, if you have an if statement within an if statement within an if statement, you have 3 levels deep. But keep in mind that an else that corresponds to one if is only 1 level deep. Okay, it's not 2 levels because the else corresponds to the if, and if there's only one if statement, it's only 1 level deep. Okay, so keep that in mind for number 6. For number 7, a set of values that will test the normal operation of this program. Defend your choices. Okay, for this you guys need to, they're basically asking you to provide a list of values that you input for X that will test all of the unique conditions within the if statements. Okay, what's called boundary conditions. They're asking you for a set of the boundary conditions within this code. Okay, and I've kind of gone over in a previous checkpoint what boundary conditions are, so you guys should be able to provide that answer by now. Okay, and I can't really get into what those are here because that would be giving you the answers for number 7. Okay, but you're looking for, in number 7, you're looking for boundary conditions. Number 8, provide a set of test values that will cause each of the test branches to be executed. These are values, there's a certain number of values that will cause at least each one of these ifs and else ifs to be executed. Okay, these are typically values that are in between your boundary conditions. Okay, so make sure you can provide a set of values that will cause each one of these branches to be executed, normally inside the boundary conditions. Okay, number 9, provide a set of test values that test the abnormal operation of this program segment. This is basically the values that are out of bounds. These are your out of bound conditions. Okay, and I've also gone over what out of bound conditions are in your previous checkpoint tutorials. But out of bound conditions are the bad conditions that'll basically are outside of the conditions that you accommodated for in this code here. Okay, so think about values that are outside of these conditions here, and that's going to be abnormal values. Okay, and there's at least 2 of those that you guys need to list there. Okay, so that basically covers the questions you guys need to provide, or questions you guys need to answer. And if you could just throw these guys here into a Word document with your answers, and I look forward to your submissions. Thanks a lot.